A set is a well-defined collection of objects. So examples for sets here I have given players of a cricket team. Sets are usually denoted by capital letters A, B, C, any alphabet letters can be used to denote a set. X is an odd natural number. So let me start with 1, 3, 5, etc. Hello everyone, a warm welcome to the first session of your PUC Mathematics. So today in this session, I'll be taking the very first chapter in the unit Sets and Functions, that is the chapter Sets. So what do you mean by sets then? A set is a well-defined collection of objects. So examples for sets here I have given players of a cricket team. So players of a cricket team is an example for a set. Student in your school is also an example for a set. Members of your family you can form in a group. So again an example for set. Ovals in English alphabets A, E, I, O, U is again a set. Prime factors of 10, namely 2 and 5. So 2 and 5 are the prime factors of 10. Again, it can form a group. So therefore, it is an example for a set. Odd natural numbers less than 8. So what are the odd natural numbers less than 8? They are 1, 3, 5, 7, which forms a well-defined collection of objects. An example for set again. Next, numbers in a dice. So when you throw a dice, what are the numbers you get? 1, 2, 3, 4, 5, 6. So these also form a collection of set. Then can we say a beautiful flowers in a garden form a set? No, because a rose may be beautiful to someone else, jasmine may be beautiful to someone else, and dairy may be beautiful to someone else. So when I say collect some beautiful flowers from garden, the perception of flowers for each person differs. So there it cannot form a set. Again, one more example is a collection of good books in a library. Novels may be good books for someone, poetry may be good books for someone, and adventurous books may be favorite to someone. So when I say collection of good books in a library, this cannot form a set. It can form only a group. So set is nothing but, as I said, it is nothing but it is well defined. So it has certain property for each elements inside the group or a set. So when you are framing a set, elements in the set contains a definite property, hence they are well defined collection of objects. In similar way, we come across a set in mathematics. We usually know that n denotes the set of natural number. Here 1, 2, 3, 4, etc. till infinite number of terms. So this is an example for a set. And integers. So integers contain the number 0, positive and negative numbers, etc. The set of all rational numbers. So rational numbers are represented in the form of P by Q, where P and Q belongs to the set of integers and Q is not equal to 0. So this is the condition for rational number. So any number of the form P by Q will form a set of rational number. The last is the set of real numbers. So real numbers contain all the rational numbers as well as irrational numbers. So it is the union of all rational and irrational number. Again, irrational number forms one more set. Now, as I said, we can just see the examples given here and we'll say whether it forms a set or it is not a set. So which of the following are sets? Justify your answer. So the collection of all months of a year beginning with letter J. So what are the months which is beginning with the letter J? The first one is January. So January. So February, no, it is not possible because the letter starting is there is F. March is not possible. April, May. So June, July is possible. June, July, August, September, October, November, December. So they cannot form a group where the letter is beginning with J. So this is an example for set. All of you will have the same answer when I give the question. That is the collection of all the months in a year beginning with letter J. So your answer will be January, June and July. So therefore, this is an example for set. Second question, the collection of 10 most talented writers of India. So as I said, 10 most talented writers of India. The idea of 10 most talented writers will change for each person. Some may so the concept of collecting the most talented writers will differ from each person to each person. So you cannot write all of them in one set. So when you have an adjective like most talented, so that does not form a set. So this is not a set. Next example, a team of 11 best cricket batsmen of the world. You have many best batsmen who plays cricket. You have many best cricket batsmen in the world. So you cannot write only 11 best cricket batsmen in the world. So therefore, this is not a set again. Next, fourth question, the collection of all boys in your class. Yes, you can collect all boys in your class. So this is an example for a set. Next, the collection of all natural numbers less than 100. So less than 100 means all the natural numbers. Natural number starts from 1, 2, 3 until less than 100 means 99. Yes, you can collect all the natural numbers from 1 to 99, which is less than 100. So therefore, this is an example for a set. The collection of novels written by the writer Munshi Premchand. So Munshi Premchand, here is the name of a person given. We can collect all the novels written by him. So yes, this is a set. Yes, the collection of all even integers. Yes, you can write all the even integer plus or minus 2, plus or minus 4, plus or minus 6, etc., etc. So therefore, you can collect it and form a group. So therefore, this is an example for a set again. Next, the collection of questions in this chapter. So yes, you can collect all the questions in this chapter. So this is an example for a set. A collection of most dangerous animals in the world. For some, lion may be dangerous. For some, cockroach may be dangerous. For some, lion may be dangerous. For some, cockroach may be dangerous. So you cannot define a most dangerous animal of the world. So therefore, it does not make any sense to form a set. So therefore, this is not a set. So now I hope you understood what is the definition of set and how the elements of set will be. So every element in a set is well defined. It is described with certain property. Next, we come across conventions in a set. So convention, how we write a set, how we denote a set, how we can write the elements in the set. See here, sets are usually denoted by capital letters A, B, C, A. Any alphabet letters can be used to denote a set. And the elements of a set are written by the small letters A, P, C, D, etc. So whenever you are going to write the elements inside the set, you are going to use only the small alphabet inside the set. So to denote a set, you are going to use capital letters, and any elements inside the set are represented using small letters. Next, when we say if an element belongs to the set A, we say or we write it as A belongs to A. This symbol is called as belongs to. So we read it as A belongs to A. Whenever the element is not in the set, we use the symbol does not belongs to. We say it as B does not belongs to A. So here I have, if A is an element of A, we symbolically write it as A belongs to A. And if B is an element which is not in the set, we symbolically write it as B does not belongs to set. Examples are given here. Suppose V is the set of vowels. I said you are going to use capital letters to denote a set. So therefore, the letter V is used to represent the set of ovals. So if V is the set of ovals, the elements in V can be A, E, I, O, U. So these are the only elements we can have. So therefore, if A, B are alphabets, if I take A, B or alphabet, we can see A is in set V. So therefore, I'll write A belongs to V. But B is not in the set V. So therefore, we write B does not belongs to V. Next example, if P is the set of prime factors of 30. So what are the factors of 30? That is 2, 3, 5, 10, 30, 15. So these are the factors of 30. But what is the condition given? What is the condition given here? They must be prime factors. So what are the prime factors of 30? That is only 3 and 5. So these are the prime factors of 30. But here I can write 3 belongs to P. If I write P, then P contains only 2 elements, that is 3 and 5. Because 3 and 5 are the only factors, prime factors of 30. You can see, even though 15 is a factor of 30, but it is not a prime factor of 30. So therefore, 15 does not belongs to this set, whereas 3 belongs to P, also 5 belongs to P. Any other factors of 30 doesn't contain in the set P. So whenever we say, so if an element is in set A, we use the symbol belongs to. If it is not in the set, we use does not belongs to symbol. So here I had taken an example so that you can just put belongs to or does not belongs to in the blank spaces. So here is the set given. A is equal to 1, 2, 3, 4, 5, 6. So what are the elements you have? Only 1, 2, 3, 4, 5, 6. Now let me fill with belongs to and does not belongs to in the blank spaces. 5-A. So what can I fill? Belongs to, because 5 contains in the set A. 8 does not belongs to. So 0 does not belongs to. 4 belongs to. 2 belongs to. 10 does not belongs to. So this is how you represent an element which belongs to or does not belongs to the set or given set. Now we come across how we represent a set. We have learned how we denote a set. A set is always denoted with a capital letters and the elements are written inside the flower brackets, and any element inside the set is written using the small alphabets. Also any numbers or alphabets. Okay. So now this is how we denote a set. But how we represent a set? So representation of sets have 2 methods. The very first method is roster or tabular form and set builder form. I'll give you an example. Set V is set of all ovals. And the same set V is A, E, I, O, U. So here we can find the difference. So here I have used the condition or any property. I am representing a property of the set by writing it in words. But here I am listing all the elements individually. So this is a difference how we can represent a set in 2 ways. So the very first method, that is defining or describing the set, is nothing but set builder form. Set builder form, and listing all the elements individually is nothing but roster or tabular form. Roster or tabular form. So roster or tabular form, in roster form, all the elements are listed. We are not going to describe its property or any character of the elements. We are listing all the elements inside the flower braces. So the elements are being separated using commas and enclosed within the braces. So that is flower brackets we can call. And here is an example I have taken. So the letters forming the word school. See, all the elements from the word you have to write, all the letters from the school should be separated using commas and written in the flower bracket. So I have used flower brackets and I have separated each letter by comma. But why doesn't O is repeated? Why we have not written like this? So if you have any letter repeated inside the set, you're going to write it only once. And the order, if you change the order also, it doesn't matter. For example, L-O-C-H-S. So here we have listed all the letters. So listing the elements inside the flower braces is roster method or tabular method. Here, the repetition of the letters is not allowed. Well, the order doesn't matter here. Next is a set builder form. So, the set builder form contains a proper, in a set builder form, the elements will contain a single property. So here the elements are not listed using the commas or it is not written inside the flower bracket. Here only the property of the set is described. For example, so here is an example. X is a, so how we will read this? So the set of all X, this is such that X is a natural number and X lies between 3 and 10. This is how we read it. Okay. So this is one more type to represent a set in set builder form. So either we can write using words like this or we can represent it like this using some mathematical symbol. So when you come across this, X is to X is a natural number and it lies between 3 and 10. What does it mean? So the set A should contain all the elements between 3 and 10. So what are the elements? 4, 5, 6, 7, 8, 9. 3 and 10 is not considered because it is between 3 and 10. So this is what? So this is roster method. And writing its property or describing its property is nothing but set builder method. We'll take few problems on how to write any set in roster form or in set builder form. Here is the question. Write the set X such that. I read this as such that. Okay. Such that X is a positive integer and X less than 4 in the roster form. So what is the condition given? X must be a positive integer. They have not denoted a set. So first let me denote a set using any capital letter. So I'll denote it by A. Then I'll open the flower braces. I'll write the elements, that is, it is a positive integer and X must be less than 4. What are the numbers which is less than 4 and it must be a positive integer? That is 1, 2, 3. So these are the only numbers which is positive integer as well as less than 4. So this is how we write this in roster form. Next. Write the set A 1, 4, 9, 16, 25 in set builder form. So here the number is listed. We are going to describe its property. So you can write like this. A start X such that. What is the condition of X here? So here you see 1, 4, 9, 16, 25, etc. They are all square numbers. So they are all square number. So you can write X is a square number, or you can denote it with one more X. So X, so where X is equal to n square such that where n belongs to the set of all natural numbers. So we know natural number contains a number from 1 to 3. So when you put n is equal to 1, 1 square is 1. When you put n is equal to 2, 2 square is 4. 3, 3 square, 4, 4 square, like that. So you can use it symbolically or just describing with words. Next question. Write the solution set for the equation x square plus x minus 2 is equal to 0. So Just find the solution. How we will find the solution? Using splitting method or by using formula method also you can do. Okay, so this I can write it as x square plus 2x minus 2 is equal to 0. X plus 2, when you take x as a common factor and here minus 1, so x plus 2 is equal to 0. So you have two solutions, x plus 2 and x minus 1. That is x is equal to minus 2 and x is equal to 1. So this is the solution. So write the solution set for the equation. So what are the solution? Minus 2 and 1. So here you can denote it with capital X. Any letter can be used. So what are the solution for this equation? One is minus 2 and another one is 1. So this is how you are going to write the solution in the roster form. Next question. Write the set 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7 in the set builder form. So you can see the numerator is 1 and the denominator is 2. So that means what? 1 by 1 plus 1 form. And similarly 2 by 3. That is 2 by 2 plus 1. Similarly 3 by 4, 3 by 3 plus 1. So we can generalize this. If n is in the numerator, then n plus 1 is in the denominator. But what is the condition of n there? The minimum number of 1 is 1 and maximum number is 6. I cannot take 7 because if you put 7, what happens? 7 by 7 plus 1, which is nothing but 7 by 8. This is not in this set. This is not in this set, so you cannot take n is equal to 7. So you can take only n is equal to 6. So how we represent this in a set builder form? So write with some set A is equal to, so x such that, what is the condition of x? X is in the form of n by n plus 1, where n lies between 6 and 1. I am using here less than or equal to. That means what? You should include 1 and 6. Suppose if you write like this. So this is wrong because n can take values of only 2, 3, 4 and 5. So you will get only the elements 2 by 3, 4 by 5. That's all. Like that. So but you want 1 by 2 also. If you want 1 by 2 and 6 by 7, then here you should use the equality symbol also. So this is how we write the condition or the property of a set in set builder form. Next, so write the following sets in roster form. So A, x such that x is an integer and lies between. I said when you have strictly less than symbol, you are not going to include the numbers which is given here. So the set here is, so between 3 and 7. So it differs. When you are using less than, it means you are going to include 1 as well as 6. Okay. But when you have strictly less than equality, when you have strictly less than inequality, you are not supposed to take minus 3 and 7. So you are writing the numbers after minus 3 and before 7. So how you can write? That is minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. Stop here. In between numbers are taken. Next, question B. X is a natural number less than 6. Simple. So what is the answer? 1, 2, 3, 4, 5. Less than 6. They have strictly told you it is less than 6. X is a 2-digit natural number such that sum of its digits is 8. Suppose if you are writing 2-digit number, for example, 1 plus 7, 70. And 1 plus 7 must be 8. This is the condition they have given. So you are going to write 2-digit natural number, but sum of its digits must be 8. So what are the numbers possible? I can denote it with C. If you write 1, then obviously it is 7. So 17 is possible. You cannot take 0, 8 because 0, 8 is not a 2-digit number. 17 26 you can write, 35 you can write, 44, 53, 62, 71, and you can write 80 because 80 is a 2-digit number. 8 plus 0 is 8. But 08 is not 2-digit number, it is a single-digit number, so you cannot write it. So this is how we list the elements. X is a prime number which is a divisor of 60. So what are the divisors of 60? So divisors of 60 are 2, 3, 4, 5, 6, 12, 10, 30, 15, 60, etc. But what is the condition here? You are going to write only the prime divisors of 60. So we know that 2 is a prime divisor of 2 is a prime number which is a divisor of 60. 3 is again 5. Next we have 10 which is not a prime number. Next we have 12 which is not a prime number. Again 15, it is not a prime number. Then 30, 60. So they do not form prime number. So we have only 3 elements, that is 2, 3 and 5. E. The set of all letters in the word trigonometry, you can write set E is equal to T, R, I, G, O, N. O is not written because it is already written. And M, E. I will not write T because already written. R, Y. So when you are given to write a letters, write it using commas. Do not repeat any letters inside the set. Next, the set of all letters in the word better. So that is set F is equal to B, E, T, R. No need to write E and T again. Next we have write the following sets in the set builder form. So in the set builder form we are doing, here is the elements given. We have to write the property of the element when you are writing it in set builder form. What are the numbers given here? 2, 4, 8, 16, 32. What you can observe? So here 2 and here 4. This is nothing but 2 square. And 8 is nothing but 2 cube. 16 is 2 power 4. And here it is 2 power 5. I'll write the condition as like this. It is the letter X, the element X, such that X is equal to 2 power n. But what is the power of n? But what is the value of n here? It is from 1 to 5. So therefore, what is the condition of n? N must be between 5 and 1. So you can put the values from 1 to 5. So remember to write equality when you are including the number before and after. So don't write equality when you are not including the numbers before and after. You can write this like this also. X is equal to 2 power n such that 0 less than n less than 6. So here it differs. So you can take the number after 0 before 6. That is number from 1 to 5. But if you are including the numbers, then write the equality. Next we have 5, 25, 125, 625. So the same property you can see here. This is 5 power 1, 5 square, 5 cube, 5 power 4. So how I can write this? X such that X is equal to 5 power n. So what is the minimum and maximum number of n? That is n can take all the values from 1 to 4. So from 1 to 4. So if you put n is equal to 1, 2, 3, 4, you will get the elements 5, 25, 125, 625. Next we have 2, 4, 6. How we can write? Very simple. X such that X is a even number. Even natural number. Also, you can mention it like this, or X is X belongs to n, n belongs to n. This is also one more condition we can write, because if you put n is equal to 1, it is 2 1s are 2. If you put n is equal to 2, 2 2s are 4. N is equal to 3, 2 3s are 6. So you will get all the even natural numbers. So this one is also possible. Next, 14900. Clearly we can see 1 is a square number, 4 is a square number, 9 is a square number, 100 is a square number. So how I can write this? As x such that x is a square number. That means it is n square. But what is the condition of n? 1 and the maximum is 10, because 10 square is 1. So it must take the values from 1 to 10. Or you can write it in words also. X is a square number from 1 to 100. Like that also you can write. Next, 3, 6, 9, 12. So 3, 6, 9, 12. Here we have 3 2s are 6, 3 3s are 9, 3 4s are 12. That means here you have multiples of 3. That is 3 into n. But what is the condition of n? N must lie between, from where to where? 3 1s are 3 2, 3 4s are 12. So this is how you are going to write any set in roster form as a set in set builder form. Next, list all the elements of the sets given here. So here is what? It is in set builder form. We are listing it, means we are supposed to write in roster form. So x is an odd natural number. So let me start with 1, 3, 5, etc. We have many odd natural numbers. So just dot dot dot. X is an integer, minus half to 9 by 2. Minus half means it takes the values minus 0.5. 9 by 2 means 4.5. So you are writing only the integer value. What is the set of integer? Integer contains only 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. So set of integer only contains these numbers, but here you have decimals. So leave the decimals and write only the number after 0.5 and before 4.5. So what are the integer value you can get here? So after 0.5, the integer value is 0. 1, 2, 3, 4. I'll stop here because it is strictly less than 4.5. The very next integer before 4.5 is 4. So the elements are 0, 1, 2, 3, 4. Next, x is an integer. X square is less than 4. The value of x square must be less than 4. What values of x can I take? I can take 0. I can take plus 1 because 1 square is 1. I can take minus 1 because minus 1 whole square is also 1. I can take plus 2 whose square is less than or equal to 4, equal to 4. Minus 2 also because it is equal to 4. So these are the only values I can take. Suppose if I take plus 3. 3 square is 9. But the condition here is less than or equal to 4. I cannot take minus 3 also because minus 3 is not possible. So the only values of x I can take here is from minus 2 to plus 2. Because whose square will be equal to 4 or less than 4. X is a letter in the word loyal. Simple. L-O-Y-A. Next. X is a month of a year not having 31 days. So easy to write. So February, April, June, September and November. So these are the months which are not having 31 days. Next, X is a consonant. X is a consonant in the English alphabets which precedes case. We are supposed to write only the consonants which precedes K. So I cannot write A, B, C, D, E, no, F, G, H, I cannot write, K I cannot write, because they clearly said it precedes K. So therefore, only consonants which precedes K is B, C, D, F, G, H. So in this session, we have learned what do you mean by set, examples for set, how we will denote a set, then a representation of set, that is roster method and set builder method, and their conversion also. So you can write any set from roster form to set builder form to roster form. So in the next session, we will be learning about the types of sets. I hope you clearly understood the concepts of sets and their representation in today's session. We'll meet you in the next session. Until then, keep watching, keep learning, and keep exploring. Thank you.